Okay guys, today we're doing 5.4, intervals of direction. Okay, so let's get started here. Okay, so the first thing here, find the formula. The formula, this is just a warm-up here. The formula gives the position of a particle at any given time. So this is a position formula, and it is given by an exponential function, e to the 3t squared. Find the t value where the particle comes to rest. Okay, so remember, based off of what we were talking about yesterday, to find where something comes to rest, that's going to be when it stops, right? So that's talking about when the velocity is equal to zero. Well, I don't have a position for velocity here. What I have is I don't have a formula for velocity here. I have a formula for position. So let's take the derivative of position, and that'll give us a formula for velocity. So velocity is going to be equal to, okay, remember how to take the derivative of this. Du e to the u. So it's the derivative of the exponent, which would be 6t, and then e to the u. We'll leave it the same, 3t squared. Okay, that's my formula for velocity. And we want to find when the particle comes to rest. So let's set this equal to 0. 6t e to the 3t squared equals 0. Okay, if we can find out when t makes this 0, we can find out when it comes to rest. Okay, remember when things are multiplying, you can set the factors of it equal to 0 itself. So I can separate this. I can do 6t equals 0, and I can do e to the 3t squared equals 0. Okay, this one right here, you divide by 6 and you get t equals 0. Okay, so there's one point at which the particle came to rest. That would be at the beginning value, where it was started at t equals 0. Okay, now this one, in order to get rid of e, you're going to natural log, right? So we're going to have 3t squared equals natural log of 0. Okay, well, I hope you remember this. What is natural log of 0? If you don't remember, let's look at a graph of natural log. It looks like this, right? Crosses right here at the 1. And remember, it never touches this line. There is no point at which natural log of 0. There is no natural log of 0. So this doesn't give you anything. We can ignore that portion. The only way to make this thing equal to 0 is by t being 0. Okay, so that's when the particle comes to rest, at t equals 0. Okay, let's do some more here. Now today what we're going to be doing is we're going to be finding when a particle or an object changes direction. And we're also going to be talking about when it's traveling to the left, when it's traveling to the right. Okay, so first let's ask the question, when does an object change direction? Okay, so if you're thinking about somebody walking, okay, it's easier to do this as an example when I'm standing in front of you, but just think of me standing in front of you and I'm walking to the right. Okay, and I decide to then stop walking and I start walking to the left. Okay, that would mean I changed my direction right here, right? In order to do this, what had to happen? Well, I had to stop. At that point, my velocity had to equal 0. And I changed direction when my velocity equals 0, and I switched from having a positive velocity to having a negative velocity. Now, would I have changed direction if I would have been walking to the right? I would have stopped. Okay, so I would have went from a positive velocity to a 0 velocity. Then I would have kept walking to the right. Did I change direction? No, right? I did not change direction. So the only way to change direction would be when my velocity went from one value, like a positive or a negative, it went to 0, then it switched to the opposite sign, right? So what we're going to be doing today is we're going to be finding when velocity is equal to 0. We're going to call these things critical numbers. I hope you guys remember doing this. You're going to set up your critical numbers, or your velocities equaling 0, on your number line, you're going to pick some numbers to the left and the right, some test points, okay? And you're going to plug these test points into velocity. Okay, so let's say I plug in, we'll call this test point 1, test point 2, test point 3. And we're going to plug all these test points into the velocity function. Okay. And let's say I plug them in and I get, at test point 1, I get a positive velocity. At test point 2, I get a negative velocity. And test point 3, I get a negative velocity. So like this positive, negative, negative. Okay, when did I change direction? Well, I changed direction right here at this critical number when the velocity was equal to 0 and it switched signs. I did not change direction here. I just came to a stop and then I continued to walk to the left. So what we're going to be doing today, and I'm going to put up the steps right now, we're going to be doing the exact same steps we used to do for finding when a function was increasing and decreasing, except we're going to be doing it for velocity to determine when something is moving to the right. Like here I can tell you it's moving to the right this entire portion of time up until its critical number. It's moving to the left from this point all the way to infinity. So we're going to be using this to determine when something changes direction and when something is traveling to the left or the right. So here are your steps. Set velocity equal to 0. Remember, this is just like before when I said find your critical numbers. Yeah? Make a number line to help you keep organized. Okay? Check to the left and the right of that value to make sure velocity changes direction. Okay, so that's only talking about if it's asking you if it changed direction. Okay, step 3 would be different if it asked you when is it moving to the left or the right, like this one. So it's the exact same steps if it's asking about the particle moving to the left or the right. So let's do a problem. Okay, the formula below gives the velocity of a particle. And I am sorry, I changed this formula. So as I was reading that, I noticed here. I did not give you a velocity. I gave a position, okay? Okay, the formula below gives the position of a particle at any point. Find the x values, and in this case it's not x, but t values, because we're talking about time, on the formula where the particle changes direction. Okay, when does the particle change direction? Okay, so first thing is we're going to have to find out when the particle came to rest. So, let's find the formula for velocity. Let's take the derivative of this. So if we bring this down, it would be 6t squared over 3, which would be 2t squared, minus, okay, that would make 18 over 2, which is 9, so 9t plus 10. That is a t, it's not a plus. Okay, so there's my formula for velocity. It said, when does the particle change direction? Okay, so first thing I need to do is find out when the velocity is equal to 0. So let's set 2t squared minus 9t plus 10 equal to 0. Okay, that's going to have to be factored. Yeah? And factoring that would give us something that looks like 2t, t, be the factors of 10, right? Which would be 5 and 2, 5 and 2. And then I'm just looking at here, both of them would have to be negative in order to give me a negative 10 there. And look at this, this would be negative 4, negative 5, making negative 9. Okay, so that gives us two answers here. You have a velocity equaling 0 at 5 over 2 and at 2. Okay, now I don't know if it changed direction at both those times. I just know that the velocity stopped. I know the person stopped moving, or the particle stopped moving at those 2 times. In order for me to check if the direction changed, I need to set up a number line, put my critical numbers on there. Okay, I'll put them in from smallest to largest. So 2 and 5 over 2. And that's the same as, if you wanted to think about this as a fraction, that's the same as 2.5, right? 2.5. Okay, now I want to pick some test points because I want to see if it changed direction at these different times. So let's pick test points before and in the middle and after all these points here. So a test point before this would be 0. Okay, a test point in the middle here, in between 2 and 2.5. Well, let's do like 2.25. And right here, test point afterwards, so let's say 10. I mean, you could use 3 if you wanted to. Okay, and also, I forgot to mention this. Both of these points counted as possible points at which you change direction because they were both positive. If I would have gotten a negative value for time, I would have ignored it because we don't deal with negative time. We only deal with positive time. So, and since both of these were positive, I put both of them on my number line. And now I need to plug all of these test points into my velocity to see if the velocity was positive or negative at all these given times. Okay, and I'm going to plug it into my easiest derivative form, which would be this one that is factored. So I'm going to have 2 times 0 minus 5. That would give me negative 5 times, if I plug in 0 minus 2, that would give me negative 2. And then negative 5 times negative 2 gives me positive 10. Okay, so that's a positive right there. It is traveling to the right. The particle is traveling to the right all the way up until time of 2. Okay, now let's check 2.25. If I plug in 2.25 here, that's going to give me, now let's think about this here. 2 times what would make this 5? 2.5, right, would make it 5. So if you put 2.25, that would make this a negative number. I don't know what negative number it's going to give me, but I'll just put down that it's a negative number. Then if we put 2.25 here, it's going to give me a positive number. So it looks like a negative times a positive is going to be a negative. So I know here it's giving me negative, which means it's traveling to the left. From 2 to 5.5, it's traveling to the left. So I know right here it changed direction. Changed direction. Because it went from traveling to the traveling to the right to traveling to the left. Okay, let's just check this last value, 10. Okay, if we plug in 10, we're going to get positive. If we plug in 10 here, we're going to get positive. Positive times a positive gives us a positive. So it's traveling to the right over here. So right here, it changed direction too. So where does the particle change direction? Well, we can say it changed direction at 5/2 and at 2. So it changed direction at both of those points. Okay, now the next question I have here is give the interval where the particle is traveling to the left. Well, it's traveling to the left from 2 to 5.5. And a lot of times they might ask you to justify. And in this case, I'm going to tell you it's traveling left because velocity is negative. Yeah? Okay. If it asked you, why do you know this is a changing direction? Because you would say, because the velocity changed signs. Yeah, it changed from positive to negative, or it changed from negative to positive. You could write that whole thing out. Okay, and that is everything for this lesson.